This is a fish swimming. On the left, there's a cylinder with water rushing past it, creating turbulent eddies called vortices that the fish can't see, but they can feel. In nature, fish swim in turbulent flows, and they surf on these vortices. Now, only if this fish were alive, but it's not. It's dead. How, then, is this fish swimming? The vortices generated from the cylinder provide the energy. The water swims the dead fish. I'm a professor at the University of Florida, a biomechanist and neuroscientist, and I study the secrets of how fish navigate unpredictable and often turbulent environments. Through the interface of life and science, my journey into the world of fish has revealed 3 lessons that I'd like to share with you today. They center around how life experiences can enable scientists to do better science, and how scientific discoveries, in turn, can help us better understand our lives. I want you to hold your breath for as long as you can, starting right now, because our first lesson takes place underwater on the coral reefs of Moorea, French Polynesia, where for hundreds of millions of years, fish have evolved to avoid misinformation. Bullethead parrotfish make beaches. Parrotfish are aquatic sheep. They meander the crystal clear waters and graze on reefs worldwide. They scrape the algae living on the corals. They have specialized teeth in the back of their throat to grind them up. They digest them, and then they poop them out. And the result is fine white sand between your toes on your tropical vacation. But where there are sheep, there are wolves. This is a black-tip reef shark, and it hunts in packs. Are you still holding your breath? Parrotfish must escape at the first sign of danger, but there's a lot of things swimming around on a coral reef. Fish must filter out false alarms from real threats. They must manage social misinformation. How do they do this? My colleague, Andrew Hind, and his team designed experiments where they recorded the responses of fish escaping from danger. What was that danger? They played scary images on underwater iPads, of course. But what they found was unusual. Fish adjust their sensitivity based on how many other fish are around them. So if you find a parrotfish in a small school, it's skittish. It reacts to any movement that might signal danger, say, to a particularly nervous individual darting away from the shadow of a cloud. But when you find a parrotfish in a large school, it doesn't do this. It's less sensitive. Parrotfish are adaptable. So it's almost like if you were running with your buddy, and all of a sudden, she dives to the side. You might jump. But if you're running with a crowd in the New York City Marathon and someone dives to the side, you just shrug. Likewise, parrotfish in large schools ignore anxious individuals, and their ability to do so over the course of their lifetime saves them energy. When is information true, and when is it not? By studying fish, we can gain insights into how to deal with misinformation in our own lives. Just as fish filter out unreliable information to preserve social stability, during elections, voters can weigh their sources. They can give more credibility to ones that are validated by facts, and they can be more critical of online viral posts. False information campaigns are a contagion. They're a disease spreading out of control. They're a school of fish that's forever escaping. Electronically, aquatically, and in person, think for yourself. Balance obtaining information from the group with your own personal observations. This trade-off minimizes the risk of group-wide misinformation while still benefiting from collective knowledge. Now, I've just shown you how the science of studying fish can hold the key to better understanding our lives, but the opposite is also true. By better understanding our own lives, we can do better science. Our second lesson takes place in Pleasantville, New York. There I am in first grade at the Bedford Road Elementary School. Pleasantville is a predominantly white suburb, and as the son of Taiwanese immigrants, at school, my lunches were rice balls and seaweed, not peanut butter jelly sandwiches. I was picked on, I was ostracized, I was bullied. I was an introvert, and I learned how to avoid social situations. If I had the chance, I would slink away. But if I was forced to stay, I found that asking questions was a good way to divert attention. I discovered that people love to talk about themselves. And at first, it took the pressure off me, but then I actually began to listen. And when I started internalizing what they were saying, I felt myself becoming transformed. What started out as a coping mechanism for my social anxiety became a way of developing genuine connection with others. So, when I started my career as an experimental biologist, I took this same approach to science. I tell my students the number one thing you can do to become a better research scientist is to listen. Not just to students and colleagues, but to the animals themselves. Experiments are a conversation with the animal. And since I don't speak fish, I have to visually listen. I have to watch them. I have to read their body language. I have to design experiments so that their behavior tells me what's important to them. And what I get from this back and forth with fish is a window into their secret world. It's like speaking another language, but on a grander cosmic scale. Case in point, there's a piece of equipment in my lab called a flow tank. It's a $60,000 engineering feat of acrylic, motors, and electronics. I can create an artificial stream on demand. I dial up a flow speed, and I can measure the oxygen consumption of any fish on Earth. Why is this technology so expensive? It's because you have to generate smooth, even flow in all areas of the tank. And it turns out this is not that easy to do. Even my expensive flow tank is not perfect. I'll dial up 100 centimeters a second, and it'll give me 90 centimeters a second in the corner. Now, to study fish swimming, you want to simplify the environment. You want the fish to swim in the middle of the tank, away from the corners and the walls. Fish swimming requires knowledge of fluid dynamics, mathematics, physiology, and neuroscience, and the simpler you can make your environment, the easier it is to say something. When you put a fish in the float tank, without exception, it swims in the areas of reduced flow. So scientists like myself, we try to cajole the fish away from the corners. We wave our arms and we jump up and down. We don't want to scare the fish like sharks do to parrotfish. We just want them to swim in the middle of the tank. The fish were telling me something early on, but I wasn't listening. Instead, I kept dancing around the tank, frustrated that I couldn't do the experiments that previous scientists could do. When I finally saw the fish, when I finally understood what they wanted, it changed my whole approach. I gave them what they wanted. I put objects in the middle of the tank to make the flow more complex, to reduce the flow, and they loved it. Through a series of experiments, they showed me that they could save energy by swimming in these complex flows in ways that were new to me and new to science. These results turned my small field of fish locomotion on its head. The energetic savings these fish were reaping were so much more than what had been found in the last several decades of research. I feel like it's getting harder for scientists to listen, to be driven by curiosity. The scientific system rewards productivity. More grants, more papers. But more productivity does not equal more understanding. And this is a communication problem. Often, we listen not to understand, but to reply. Do we experiment to understand, or do we experiment to publish? Listening is a strange thing. Far from being the passive collection of information, true listening is a magnetic and creative force and can bring you to new vistas of perspective. I work at a marine lab. My office is steps away from the animals I study. I open the door, I cross the street, I step onto the beach, and I look out over the Atlantic Ocean, where for millions of years, these animals have been going about their daily lives, till I happen to stop by for a relative nanosecond. Now, this does something to you as a scientist. It changes the shape of your thoughts. Animals are not call and response machines. They require natural habitats to reveal their true selves. Their responses need to be considered before designing the next experiments. And I do this by watching them all the time in the lab, on the water, fishing with my son, scuba diving, peering through a microscope with students. Watching fish lets me know what new experiments to do, rather than show up with a preconceived notion of what I or other scientists think we should be doing. This perspective is subtle but powerful, and it's led to many new insights in my career. Real communication, whether with the natural world or with people, is about how you listen. When you suspend yourself in this state of vulnerability and openness, when you relinquish control, you get out of your head and into another worldview. The third and final lesson comes from my father. I grew up fishing with him in New York City. Vacations weren't something we did, so boredom was often my weekend companion. Catching nothing from a condemned pier on the East River, poking around for frogs on the littered shores of a duck pond in Brooklyn's Prospect Park. Fishing was more than a pastime. It braided life with science. I spent my childhood on the banks of the Sawmill River, watching trout swim and flow, darting out behind rocks and logs to catch insects. Fishing allowed me to observe, to watch how animals move, to see where they like to be. And as life would have it, many years later, I found myself in graduate school at Harvard University, staring at tanks of fish, pondering what I could contribute to science. And while most of my field was interested in the effect of fin shapes and body morphologies on swimming efficiency, I thought back to the fish of my youth. Trout don't just swim in smooth flow. They're often found in areas of turbulence. So I set out to recreate this in the lab, only with some fancy equipment. Now, to study fish swimming, you need to know more than how their bodies move. You need to know how those motions affect the water around it. Water is what fish push off of to propel themselves forward, not the ground, like us. And to do this, you must measure three-dimensional forces. You must look at the motions of the water itself. You must visualize fish footprints. How do you see the invisible? You need lasers to light up particles in the water. You need high-speed video cameras to capture the motions of those particles so you can record the flow patterns. And using this technology, I watched as vortices peeled off cylinders, mimicking rocks and logs. And I discovered that fish could exploit turbulence to save in the cost of locomotion. This was the animal using energy already in the environment to do their bidding. This is like an eagle soaring on a thermal. This is like a sailboat tacking upwind. This is the harmonious use of the vortices that life throws at you. Do you remember that dead fish swimming video? This is what real salmon do, and it is a lot more passive than we previously thought. I showed these results to my father, and he said, "Oh, that's Wu Wei. It's a Taoist philosophy that means to go with the flow, to do nothing and yet everything gets done, to move with the natural streamlines through the currents in your life." And when he said this, something inside me clicked, and I started to think about my life differently. My relationship with my father was sometimes turbulent, but through fishing we forged a bond. He had a temper and occasionally was violent. It didn't break me, but it left me confused, hurt, and resentful. Watching fish turn a negative obstacle, like a strong vortex, into a positive force to help them move upstream was something that I needed to know. And it was the fish that my dad first introduced me to that taught me this. I'm a father now. My son is about the same age as I was when my father first started to take me fishing. Now when I go fishing with my son, I have my dad's stern voice, and it scares him. And the other day, we talked about it. When you get too close to the water, I raise my voice because I'm scared. You don't know how to swim yet. And plus, there's alligators. Do not tell your mom that. He thought about this for a moment, and then his eyes met mine. Yelling works for you, but not for the other person. I took that in. Now I ask him nicely if there are no alligators, and he listens. But so am I. When I'm fishing with my son, I'm still listening to fish. My curiosity is bigger than my work. It's my life. I just simply bring it into the lab as another way to understand all of this. Curiosity is agendaless. I would love to see a world where science is justified by curiosity in the same way that art is justified by beauty. I would love to see a world where goallessness is embraced by public taxpayers, by politicians, but this is tricky. It takes trust. After all, the goal of a plumber to fix the toilet is not optional. But in my line of work, having goals can sometimes put on blinders. I have to keep emptying the cup for it to be useful. Oscar Wilde said, "The self-conscious aim of life is to find expression." He was talking about expression through art. Here, I'm talking about expression through science. How we live our lives profoundly affects how we observe the world. My personal life is my professional life, and my professional life shapes my personal life. When I listen to my whole self, synergies bring me to unexpected places. Science is personal. Sure, it has rules, but there's passion that's flowing through those rules. Science is at its best when we bring our determination, our doubts, our obsession, our pain, our excitement, when we bring our history. We're not that different from our underwater cousins. Alive or dead, fish have lessons to teach us. Now, to be clear, I don't have all the answers, but I know that if I continue to ask questions from both sides of myself, that someday, maybe, I'll find that fish do. Thank you.